Shingapur.
Hello everyone, how are you all? And how many of you gave the interview? How many of you appeared for the interview? I am fine. Thanks for asking. How many of you gave the interview? Tell me. Are you silent?
Doctor said, but we are having this medicine.
Yeah, what had happened? Hello. Yeah, hello. Am I audible correctly?
Yes, sir.
Yes, sir.
तो कितनों का इंटरव्यू हो गया?
Yes, sir.
कितनों का इंटरव्यू हो गया पहले बताओ?
अभी तो नहीं किया सर।
कितनों का पूछ रहा हूँ ना, हो गया कितनों का? किन्होंने दे दिया?
सर उस सीट में बहुत कम लोग ही है अभी तक।
तुमने दिया?
नहीं सर, मेरा छुट्टी नहीं मिला अभी तक।
मतलब क्या? अच्छा, तुम जॉब करते हो?
जी सर।
ओके, कहाँ पर?
बेंगलुरु में ही हूँ सर।
वेरी गुड। मतलब आईटी सेक्टर में या नॉन आईटी सेक्टर में, कहाँ जॉब करते हो?
रिटेल सर।
ओके, गुड गुड।
नॉन आईटी।
तो फिर आईटी में क्यों आना चाहते हो? ऐसा क्या है आईटी में?
कुछ नहीं सर, दुनिया जिसमें चलता है पैसा।
ओके
सुखी जिंदगी है आपकी जैसी।
ओके, चलो बढ़िया। कुछ मोटिवेशन होना चाहिए ना। अच्छा, आप में से कितने लोग यहाँ पे कंप्यूटर साइंस बैकग्राउंड से हो?
मैं सर
स्वप्निल, यू आर फ्रॉम सीएस बैकग्राउंड?
मतलब अभी चालू है सीएस।
अच्छा, कौन से क्लास में, सॉरी कौन से कॉलेज में हो?
संत गाडगे बाबा, अमरावती यूनिवर्सिटी।
ओके, अच्छा मेमन भी है?
सर मैं भी मतलब कॉलेज ज्वाइन करना है।
कॉलेज ज्वाइन एमटेक करना है या बीटेक करना है?
सर अभी तो नहीं देखा सर, 12 पास आउट ही हुए बस।
12th पास हो?
यस सर।
तो यहाँ क्यों आए, मतलब यहाँ क्या कर रहे हो? अभी तो इंजीनियरिंग भी नहीं की यार, मतलब 12th के बाद ही जॉब चाहिए ऐसा कुछ, या फिर अभी डिग्री करना है?
सर इंटरेस्टिंग लगा तभी, इंटरेस्टेड थे तभी।
चलो सही है, सीख के रखना अच्छा है, बहुत अच्छे।
सर इसलिए समझ में नहीं आता कुछ कुछ तो।
मतलब तुम बहुत सारी चीजें पहले ही सीख जा रहे हो, यही
Yes,
बात
sir.
है। तो 4 साल पढ़ा हुआ है
सर जी
सीखने
अभी
के लिए।
सर सच में क्या है सर, 12th में जो छोटे छोटे बेसिक थे वही सर अभी एडवांस में चल रहे हैं इसमें कोर्स में।
तो आप में से ऐसे कितने लोग हो जो अभी बस 12th किया हुआ है, 12th करके यहाँ गए हो, आप कॉलेज जाने वाले हो? आप में से ऐसे कितने लोग हो यहाँ पे? हेलो?
शायद मैं ही हूँ सर only।
और मेमोन,
मैं तो
आप एमटेक करने जा रहे हो ऐसा कुछ?
नो सर, जुनेद मिर्जा जुनेद एंड सर, मैंने जो है ना रिसेंटली अभी डिप्लोमा कंप्लीट किया है और अभी बीटेक में
Okay.
एडमिशन ले लिया।
चलो सही है फिर।
यस सर।
तो बहुत सारी चीज तो सीख ही गए यार।
यस
तो
सर।
फिर 3 साल पढ़ा हुआ है, सीपी करना इसके बाद, ठीक है?
यस सर।
कंपैरेटिव प्रोग्रामिंग अच्छे से कोड शेफ करना अब।
सर
Okay,
हमें भी
sir.
थोड़ा बहुत बता दीजिए क्या लें।
ठीक है, मतलब कंप्यूटर साइंस जिनको पढ़ना है मेरे से बात कर सकते हो, मैं बता दूंगा करना क्या क्या है।
यस
ठीक
सर
है।
मुझे करना है।
तो 4 साल है, फर्स्ट ईयर थोड़ा एंजॉय करो, उसके बाद शुरू करना, मैं यही बोलूंगा जो हमने किया अपने वक्त में।
ओके
करना चाहते हो तो कोड शिफ्ट, हल्का फुल्का कोड शिफ्ट शुरू कर सकते हो, ठीक है?
सर जब नहीं आता था तो एंजॉयमेंट हो गया, अभी तो पढ़ना है सिर्फ।
हाँ सो भी है। चलो हो गया बहुत बात, लेट्स स्टार्ट विद टुडे सेशन ऑपरेटिंग सिस्टम। ओके, चलो मैंने सब कुछ सेटअप कर लिया है इन द मीनवाइल। ओके, एवरीवन कैन सी माय स्क्रीन?
यस सर।
Okay, so can anybody tell me what do you mean by an operating system? What is an operating system? Can give me an example, someone, what operating system you have seen in day-to-day life?
So Windows OS.
Okay, Windows. How
Mac.
many Windows have you
Windows.
used? Windows versions?
So Windows X, Windows 7, Windows 8, 8.1, 10.
XP।
सर फ्रॉम विंडो
10,
97 टू विंडो 11।
97, right? First, then 97 somebody has used, then XP, then has anybody used Windows Vista? Vista
Yes, sir.
version?
यस सर मी।
And next
Windows 7 sir.
Windows 7, then Windows 8, currently मैं
8.
यूजर हूँ 8 का। उसके बाद
8.1.
8.1 and 10।
ओके, वही एक ही बात है, 8, 8.1, ठीक है। Now next
10
10.
sir.
10, and right now Windows 11 is there.
11.
Yes sir.
Okay, any other? This Windows is an operating system. Any
sir,
other operating system?
सर लिनक्स है।
Linux. What versions you know of Linux?
सर Ubuntu,
Ubuntu, right? Next,
Kali,
yeah, Kali. Kali is used for
hacking.
hacking.
और यस सर।
Hacking version of Linux. Kali.
Yes,
Next,
और सर मैक है, और सर इतने दो ही यूज किया हूं मैंने तो।
चलो Mac. Apple users.
सर मैक का आइडिया नहीं है।
Mac. चलो बहुत versions है. I haven't used Mac any day. I haven't used Mac. Linux, Ubuntu I have used. XP, Vista, 8 I have used. 10, yeah, and 10. These all operating systems I have used. And yeah, Kali हल्का फुल्का चलो चलाना आता है, यही बात है। So what do you mean by an operating system? There are so many. अच्छा, any mobile operating systems you know? Those who
Android,
use
sir.
smartphones.
Android, iOS,
Android and iOS. Next,
जावा,
Symbian,
Symbian, right?
जावा,
Java. Why Java?
जावा
जावा का भी था, जावा एक ऑपरेटिंग सिस्टम था सर,
Java
सैमसंग वाला फोन पे आता था।
नहीं
is
सर,
it?
नोकिया का भी था जावा।
वो कीपैड वगैरह में आता था पहले शायद।
होता
नहीं,
होगा।
सैमसंग का,
है।
सैमसंग चैट जब छोटा वाला निकला था ना, वो टाइम पे जावा ऑपरेटिंग सिस्टम ही चल रहा था।
यस,
Okay.
जावा था पहले।
जावा ही पे ऑपरेट होते थे सारे।
ठीक है, चलो तो ये तीन अभी अप्रोप्रिएट, मोस्ट अप्रोप्रिएट अभी यही तीनों है, एंड्रॉइड, आईओएस और कुछ कुछ मोबाइल सिम्बियन पे चलता है, बहुत पुराने मोबाइल्स। तो व्हाट डू यू मीन बाय एन ऑपरेटिंग सिस्टम? व्हाट डू यू मीन बाय एन ऑपरेटिंग सिस्टम? कैन एनीबॉडी गिव मी एन डेफिनेशन ऑफ दैट? What is an operating system, by the way?
To run the system.
Yeah, means that is its function, right? Operating system's function is to run the system, you can say. But what is an operating system in simple terms?
सर which we can operate.
So interaction between the computer and the operator.
Yeah, but any simple definition that you can give, what is it?
Conversion of user language into machine language.
Yeah, very good. That is its function. That is its function. But what it is?
Communicate with hardware also.
What it is? What is an operating system?
Software programming system.
Yes, operating system is a software. Is it? First point, what is it? A software. Nobody told me this, that operating system is a software. Now, what it does? It is a software. What is the role of it? Why do we require this? This operating system acts as an interface between user and computer hardware. Anything else? It does what? Whatever instruction through the hardwares of the computer I will be giving, operating system is the one that is responsible for executing those requests and giving me the result. Who gives that? Operating system does that. How? How it does that? I will give that, okay, such and such command I have given to the computer. Okay, this is command 1, command 2, command 3. I will give it to the computer. Operating system is responsible for taking those commands. Now, how it will execute them so that I get my appropriate results? How? It will direct those commands to the appropriate applications. Suppose that I want to print any document. I have given the print command. Operating system detects that, okay, now print command has arrived. What it will do, it will trigger the prints. It will trigger the printer. Okay, it will trigger the printer and it will give you meaningful output. That, okay, something will be now coming out on a paper. The required document elements that I wanted to print, operating system has triggered the printer. That, okay, now you have to print this, see, and okay, on a paper I will be getting my output. But before going to this printer, what happens? Before anything comes out of the printer, what happens? It designates the command. Whatever print I want to do, it redirects the command to some application, right, inside the computer. That what kind of activity you want to do. Do you want to print in portrait or in landscape version? Do you want to print on both sides? So what it is doing, apart from interacting with the hardware, what it is doing, it is triggering the necessary application also, which is responsible for taking necessary inputs. That, okay, what kind of print you want to do, right? So what operating system does apart from interacting with the hardware, and it interacts with application also. OS interacts with applications also, application softwares also. Okay, that okay, my user has arrived, user wants to use you. Please start yourself. I am giving you the necessary resources. Please start yourself and execute. It interacts with the application software so that user can bring out meaningful outputs from those softwares. Getting those points or not? First tell me that. Are all these points clear? What is an operating system? What it does? So one thing we can say, operating system, just a minute. Operating system provides me with necessary environment. Operating system provides necessary environment. Operating system provides necessary environment to execute programs, or to execute programs. Fine. I am right now executing this open board application. Right now I am utilizing this open board application, and inside that I am writing, right? Who has provided me where I can run it? Inside some environment. Who has provided that environment? The operating system. Inside that, operating system has provided me the environment in which I have started the open board application. Open board application, and inside that I am writing the necessary output, necessary things that I require to teach you people. Okay, getting that point. And allow, not only this open board is running, many other applications and processes are running counter along with. How can we check that? How many processes are going on? Can anybody tell me? Can anybody tell me? How can I check? How can I check how many processes are going on?
Taskbar.
By opening task manager.
Yes, open the task manager. Open the task manager and see what these are, what processes, what applications are being processed right now. Google Chrome, open board, task manager itself is a process. My Visual Studio Code, see Zoom meetings, 2 tabs are opened. And see, each and every are requiring some kind of CPU operations. Is it? Operating system is executing them. So how much of the total CPU is occupied right now? That is being given here, 25%, 21%. How much is the total amount of memory being occupied by all programs right now? 64%. How much is the disk space required? 1%, 2%, these things. What is the difference between a disk space and memory? What do you think?
So what is CPU portal?
CPU, how much CPU is being utilized right now? how much you can say, how much is my CPU occupied with the processes? This is what being seen here. It has a limit, say, let's say my
Occupied what? It's space
no, no.
or sufficiency?
Let's say my CPU can perform 100 tasks at one go. Okay. So yeah, if 100 tasks is the maximum limit right now, how many are recently being executed? This is what the CPU is showing. How much percent my CPU utilization is happening.
So means
Total-
out of 100, it is occupying 12 or 15%, 12 to 15%
Yeah,
now.
right now. Yeah. So it has more capacity to that. Okay. Right now, if more processes are given to it, it can simultaneously execute. But yeah, that time the percentage will increase. Okay. That time the percentage will get increased.
So sir, at certain level, it stops.
Yeah,
out of
at
the
certain
state.
levels it cannot take anything more, and if such kind of errors you get, the CPU will trigger a restart. The operating system operating system has some inputs in it that okay, if beyond this percentage the number of processes are going, it will start killing the process, and it will, if it finds necessary, it will trigger a restart automatically. It will trigger a restart in your computer. Operating system is responsible for all those things.
Okay, so
Okay. So yeah, let's move on. So what are the functions of an operating system? What are the functions of an operating system? Let me close my taskbar also. What do you think? What are the functions of an operating system? What functions it performs? Okay, before coming to the functions, shall I go to some other topic? This is what I'm thinking. Okay, yeah, let's go one by one. What are the functions of a CPU? What do you think? What are the processes of a CPU? Okay, before coming here, let me introduce you with some other terms. Okay. What are the types of operating system? What are the types of, anybody knows what are the types of operating system? Types. What are the types of operating system?
32 or 64 bits.
Not exactly. Not a, what are the types of operating system you know?
The types means Windows, Mac. That
No,
like
no,
that.
not like that. What are the types? Based upon
हाँ सर
function.
टाइप्स
तो पीसी के लिए एक हो सकता है, मोबाइल के लिए
सिस्टम, कंप्यूटर ऑपरेटिंग से, नेटवर्क के लिए
नेटवर्क तो
के
तुम्हारा नॉर्मल जो एक कंप्यूटर ऑपरेटिंग सिस्टम एक है, वही तो नेटवर्किंग संभालता है, वही तो नेटवर्किंग. इसके अंदर पोर्ट्स, some port softwares are there. Those are responsible for your data exchange. पोर्ट के थ्रू डेटा एक्सचेंज होता है. Why do we require and separate operating system for networking? Okay, many answers I am getting. Batch OS, distributed OS, multitasking OS, real-time operating system, mobile OS, network OS, embedded OS, or embedded OS, or handheld system. किसी ने नाम सुना है? चलो और आ रहा है. Chrome OS, CentOS, FreeBSD, Solaris, और CentOS. Multiprocessor system. Does anybody know about that? Multiprocessor.
No, sir.
Multitasking OS. अच्छा. Anything else? चलो एक तो टाइप मिल गया, multitasking. Two types. We have
batch operating system.
one is, let's say, single processor systems, let's say. Next, multiprocessor system. Another can be time sharing. Okay, so what happens inside a single processor system? What do you think? There is a single processor inside my computers. Processes come one by one. Let's say P1, P2, P3. These processes comes one by one into the CPU. They get executed one by one. Okay. First, let's say this P1 will be executed. Okay. This P1 will be executed. It will give the necessary output. Then P2 will, let's say P2 will be executed. It will give some output. and then P3 will be executed, and it will give some necessary output. So what is happening here? Not more than one task. Not more than one task at a time, right? Is it happening? Not more than one task at a time executes inside single processor systems. Okay, not more than one task at a time gets executed. Right? So can you tell me something about multiprocessor systems? What happens here? Can you tell me something about that? Can anyone have any guess that, okay, inside single processor systems, what happens? There is a single processor P. Okay, this processor is responsible for executing the process that are coming. So not more than one process comes inside the CPU and gets executed. Now let's say one by one, process P1, P2, and P3 comes inside the processor. It gets executed and gives their outputs one by one. Output 1, output 2, output 3.
So 3 tasks at a time.
Not 3 tasks, one task at a time. First P1 will be executed, then P2 will be executed, then P3 will be executed. One by one, not together. One by one.
They can't execute together.
No. Getting the point?
Yes, sir.
Yes.
So try to tell me something. What do you mean by multiprocessor systems?
Multiprocessor can do all the tasks simultaneously.
Is it? I don't think so. All task is not possible, right? All task is not at all possible. What do you think? Multiprocessor, what does the term says?
Multiple
one
processors,
processor will do
more than
multitasking.
one.
Yes, sir,
Okay.
more than one.
Multiprocessor, what does the term says?
So one task performed by
Multiprocessor means there will be more than one task, right? There will be more than one processor, sorry. More than one task will always be there. Let's say 4 processors are there, 4. So now let's say this is my processor 1, processor 2, processor 3, processor 4. Processor 1, processor 2, processor 3, processor 4. Now let's say task 1, task 2, task 3, task 4. They arrive for execution. Then what can be the possible scenario that can happen here?
T1 will be assigned to P1, T2 will be assigned to P2, T3 will be assigned to P3, and T4 will be assigned to T4.
Yeah.
And all the process are complete in one time.
So we can
And
say
they-
that task 1, when task 1 arrives, the operating system will look for which processor is empty. Operating system will look for which processor right now is vacant, empty, does not have any process to execute. It will assign it there. Let's say first it assigns processor 1, T1 to processor 1. Now T2 simultaneously I can assign to any of the P2, P3, P4. Let's say it is assigned to P2. Task 3 arrives. Now let's say it is assigned to P3. And let's say task 4 arrives. It is only one processor is left, P4. It is arrived. It is given to that. So right now I can say processor 1 is allotted to task 1, processor 2 is allotted to task 2, processor 3 is allotted to task 3, and processor 4 is allotted to task 4. What had happened? Each of my processor is executing a process separately. Okay. So we can say that a processor that we have does not execute more than one processor at a time. More than one process at a time. it does not execute. Okay, so multiprocessor, if a system is multiprocessor, what is the advantage? If a system is multiprocessing, what is the advantage as compared to single processor systems?
सर मल्टीपल फास्ट
Mul-
होगा.
multiple tasks we can perform, right? We can perform multiple tasks. Multiple tasks can be performed. Next, what advantage else?
Time saving.
No, next advantage that I will get from multiprocessor systems.
So fast work.
Faster is definitely right. What? Per unit time. Per unit time, more amount of work. Is it? Is it or not?
Yes, sir.
Yes.
More amount of time, more amount of work. Amount of work that a user can do inside a multiprocessor system is more as compared to a single processor system. Correct or not?
Yes.
Okay. Okay. What else can you observe from here? What else? What else? Okay, now let's say process 5 comes and all processors are waiting for their time to finish, right? All the processors are waiting for each task to get finished. So when each of the processors are occupied with respective processes, can P5 enter any of the processors? Is it true?
No.
Why?
Because all the processors are busy.
All the processors are busy, right? It cannot execute right now. This process 5. One, suppose this T3 is the first one that completes its execution. Then why I can say that, okay, now processor 3 becomes empty, becomes vacant. So I can, let's say this is T5, task 5. I can assign it to processor 3 for carrying out the execution of task 5, right? No processor can execute more than one process at a time. Okay, no processor can execute more than one process at a time. Okay, always this is the fundamental you have to remember. Anything else that you can suggest me here? Multiple tasks can be performed per unit time, more amount of work. Now tell me what else you can see here. Anything else that we can tell from here? Multiprocessor. Is the cost of this, whose cost is more? Cost of multiprocessor system is more or cost of single processor system is more?
Sir,
Multiprocessor is more.
Why?
Because there is many processor. built.
Cost is more, right? Cost is more. Whose performance is better, multiprocessor or single processor?
Multiprocessor.
Multiprocessor, right? Its performance is far better. This is what I think. Per unit time, more amount of work, right? This is what we have already mentioned, that performance is better, enhanced performance. Okay, so I think why cost is more? Because more amount of processors are there, right? Fine, multiprocessor, little bit we have seen. Now let's go to, is this point clear to all of you? What is a multiprocessor system? Tell me that.
Yes, sir.
Yes, sir, clear.
All of you?
Yes, sir.
Akka.
So there's
Yes,
one
sir.
question.
Tell me.
So do we use a single processor now?
Sorry.
So currently are we using single processor?
It may happen at some point. maybe some systems are maybe there which can
There is a octa core, sir.
We were using this earlier, no, but now I don't think we are using it. If you are using it, where we using it?
need to find out, need to see. Actually, there may be some use cases of it also. Okay, it may be, there may be some use cases where this single type processor may be utilized. Okay,
But so for now, multiprocessor is popular.
yeah, at major you can say major work areas, these multiprocessor things are used. Else the performance and performance meetup, as well as the time in which the execution should happen, these things will not be there. Okay,
Okay, sir.
but one thing, don't we use only one processors in our home computers? What do you think?
No, sir.
Is it?
What, sir?
Some multi-processor, sir.
Is it? ऐसा है, प्रोसेसर तो एक ही लगा हुआ होता है, मल्टी प्रोसेसर कहाँ कहाँ 2-3 प्रोसेसर चिप्स कहाँ पे आता है?
No,
Laptops and
sir. One
computers
processor के अंदर होगा ना.
प्रोसेसर के अंदर प्रोसेसर होगा.
Yes, sir.
ये कहाँ से मालूम पड़ा?
मल्टीपल थ्रेडेड होता है कुछ.
Yes, sir. Thread होते हैं.
ये क्या चीज होता है? थ्रेड क्या चीज होता है? हमें भी बताओ.
ये नहीं पता सर.
Multi threading.
डिटेल नहीं आता सर.
मुझसे पूछ रहे हो एक सवाल. सिंगल प्रोसेसर, यस, मेजोरिटी ऑफ इंडस्ट्रीज में तो चलो मल्टी प्रोसेसर ही होता है सब कुछ, मान वहां पे बहुत एडवांस होता है हर चीज. इंडस्ट्रीज बोलो, सुपर कंप्यूटर्स बोलो, उनकी बात ही अलग है. ठीक है, मेरा एक दोस्त गया था IIIT में इंटर्नशिप करने, तो वहां पे उसने हाई फाई कंप्यूटर्स को यूटिलाइज किया था, मतलब कि सुपर कंप्यूटर टाइप्स थिंग्स. ओके, फॉर हिज इंटर्नशिप. So these things are very advanced things, supercomputer types. But fact is, in our computers, don't we have only single processor?
Yeah.
Only one processor resides on it. First tell me that.
Yes, एक ही है.
Then, sir, how we are able to do multitasking?
Yes, sir.
Actually, you get the feel of multitasking. You get the feel that we are doing multiple tasks. You actually, any processor, let it be, it don't do any multitasking. Let it be single only, it will not do any kind of multitasking. At a time, it will do execute single task only. You get the feeling that, okay, you get the feeling that right now multiple tasks are happening side by side, but actually it is not the case at one time.
तो फिर उसका प्रोसेस भी ज्यादा है क्या, ऐसा बोलना है आपका?
यस, प्रोसेसर्स देखो, मेरे कंप्यूटर, अभी हमने कंप्यूटर्स में क्या देखा, कितने प्रोसेसर्स थे?
एक सिंगल.
इज इट सिंगल प्रोसेसर? इतना सारा प्रोसेस है, देखो तो कितना प्रोसेसर. गूगल क्रोम चल रहा है, ओपन बोर्ड
चल रहा है, प्रोसेसर एक ही है ना.
प्रोसेसर तो एक ही है, पर इतना सारा प्रोसेस तो चल रहा है ना. बैकग्राउंड प्रोसेस, सी,
हाँ,
at the background how many processes are going? I've asked. This entire antivirus is running. This is background process.
Yes.
Okay, so many other processes are that are required for operating system to run those things. Such many services are also running up, right?
Yes.
That are required for running the operating system itself. Actually, our operating system is a collection of softwares together, collection of application softwares together, and that in turn manages and runs several other softwares, or helps running them, you can say. Fine. Now let's see another type called what? Time sharing, right? What is time sharing? What is time sharing operating systems? What is it? What do you think? Time sharing. Anything you can take out from the name time sharing operating system?
सर many प्रोसेसर एक साथ वर्क करे तो टाइम शेयरिंग.
Is it? मुझे तो नहीं लगता. अभी तो वो तो मल्टी प्रोसेसर के अंडर चला गया ना. What do we mean by time sharing OS? Many multiple processors will be there, no doubt. Multiple processors are there here, but
सर एक प्रोसेसर एक वर्क ना करके सारे कर रहे हो तो
कैसे करेगा? क्या काम है ऐसा? Let's suppose T1, T2, T3, T4, T5. 5 process I want to execute, but all should be executed side by side. How it will be happening? Another, let's say T6 should also be there. And now, right now, let's say, let's assume that, okay, 4 processors are pretty much. Let's say 2 processors are there inside my current computer. Tell me, how shall I execute T1, T2, T3, T4, T5, T6? Or let's say 4 processors are there, not to go with 2 T5 and T6, 4 processes I want to execute. How time sharing will manage them? What will happen? See what operating system will do. Okay, operating system will fix the time. Let's say 5 nanoseconds. 5 nanoseconds. It has fixed a time. Okay, now it will allot T1, process T1 to P1, processor P1 for 5 nanoseconds. Processor P1 gets T1 for 5 nanoseconds. Processor P2 gets task T2 for 5 nanoseconds. Okay, now these tasks T1 and T2 will get executed for 5 nanoseconds, let's say. Now T1 will be asked to stop. Okay, you have executed for 5 nanoseconds, stop. For another 5 nanoseconds, let's say T3 will be given to P1. Now for the rest coming 5 nanoseconds, T3 will be executed at P1. Okay, similarly after 5 nanoseconds, T2 will be asked to stop. Okay, that you stop your execution. I will give T4 to run inside, to get execute inside the processor P2 for coming 5 nanoseconds. So you're getting one thing. What is happening here? They are sharing times. Getting the point?
Yes, sir.
Processor P2 is been executed by 2 processes, T2 and T4. P1 is being utilized by 2 processes, T1 and T3, right? For time 0 to 5 nanoseconds, T1 will be executing inside it. Now for the coming 5 to 10 nanoseconds, from 5 to 10 nanoseconds, T3 will be executing inside it. Now again, from 11, it will be from 6, sorry, 11 to 15 nanoseconds, process T1 again will take over to P1 for execution. Now for coming 15 to 20 nanoseconds again, T3 will be executing inside P1. This will go on till both of them get their entire execution done. Similarly, can anybody tell me what will happen inside P2 when if T2 and T4 both are getting executed at P2? What will happen?
सेम होगा जैसा T1 T3 के लिए हुआ.
क्या होगा? Okay, inside P2 processor P2, what will happen? For the first
T1
for 0 to 5 nanoseconds, which process will be happening here, taking place here?
T2.
T2, right? And for 6 to 10 nanoseconds, which process will be taking here?
T4.
Take place here. This
T4.
T2, let's say this T2 will be stopped for a while. Computer OS operating system will ask it to stop for a while. You stop for a while, you pause. You have not completed, pause down for some time. For 5 nanoseconds, you pause. Okay. So in the meanwhile, for the 6 to 10 nanoseconds, it will ask T4 that, okay, now you can begin your execution here. You can begin your execution here. For 6 to 10 nanoseconds, T4 will be executing here. After it has executed, now T4 will be asked to pause for a while. Now operating system will ask again to process T2 that, okay, you can begin again now. Now it will again begin from 10 to 11 to 15 nanoseconds. Fine. Now again, once it has completed 5 nanoseconds of execution. T2 will be paused again, suppose, and then again T4 will be beginning its execution from 16 to 20 nanoseconds, right? And this execution, turn by turn execution, will go on till both of them gets completed. Getting the point? How time sharing happens?
Yes, sir.
All of you, is it
It
clear?
goes on, this exchange of tasks will goes on till the completion of the task.
Yes, till the completion of the term. This is how our real-time systems work. Actually, you are seeing, okay, that how many seconds do we deal in seconds, right? We human deal in seconds. For us, seconds matter. The lowest time that we can detect or blink our eyes in seconds, is it? But yeah, computers do work in nanoseconds. So till the time we can feel any change, computer has already executed a process, let's say 50%. What, let me show you an example. Let me give you an example. Let's say I am listening to a song also. I am listening to a song also, as well as I am surfing internet. I am surfing internet inside my computer, okay? So what happens is that both of them, let's say only one processor I have inside my computer, only one. So how it will be executed? Computer will fix a time limit for executing both. Let's say 5 nanoseconds. For first 5 nanoseconds, this song will be executing. Then again for next 5 nanoseconds, my internet, whatever browser I am browsing, those requests I am making, okay, request to the browsers I am making, any game I am playing there on the internet online. So what happens, that process will be carried out by the operating system. But yeah, 5 nanosecond is a too small time for us to detect, right? We cannot actually detect what is 5 nanoseconds. What we can see, changes in seconds only. Changes in seconds only. So by the time I can detect any change, this process also has gone ahead, right? This process has also gone ahead by some percentage. This process has also gone ahead by some percentage, by some percent. So we can assume that we get that, okay, both processes are going ahead, both are getting executed. That means we feel both are simultaneously executed, as in something like that is happening. But actually both of them are executing one by one, turn by turn. So this is how time sharing operating system works. Tell me one thing, have you understood this or not?
Yes, sir.
बट सर ये भी तो मल्टीटास्किंग में आएगा.
मल्टीटास्क कैसे हो रहा है? मान लो
क्योंकि सर शेयर कर रहे हैं ना वो.
ठीक है, हाँ, मल्टीटास्किंग हो रहा है, ठीक है, एक ही को शेयर कर रहा है, मल्टीटास्किंग हो रहा है, कह सकते हो. बट कैसे हो रहा है? टाइम को शेयर करके, टाइम को डिवाइड कर दिया, इतने टाइम के लिए एक रहेगा, इतने टाइम के लिए एक रहेगा. कह सकते हो मल्टीटास्क, it is multitasking, okay, it is multitasking. But how? We are not sharing the CPUs, we are sharing the CPUs by dividing time among ourselves, okay. कह सकते हो. We get the feeling that, okay, this is a multitasking thing, but actually in the real scenario, CPU is executing only one process at a time, okay. Not parallel processes. Parallel processing is not happening, okay. Inside a single CPU, parallel process is not happening. So time sharing is what? Yeah, that's all. Okay. Parallel processes, likewise we have got inside multitasking. Sorry, multiprocessor systems. Multiprocessor system, multitasking we can achieve, right? Because we can say that, okay, process P1 is inside another CPU, process P2 is inside another CPU. But there is only, let's say, single CPU, and inside which I want to, and that is a time sharing, okay, that is time sharing. What we say that, okay, inside there is no parallel execution. P1 and P2 will definitely execute one by one inside a single CPU, but they will divide time among themselves. That, okay, P1 has some separate time of execution, P2 has some separate time of execution. But the time of execution, the context switch, sorry, the switching between them happens in so less time that, okay, we detect the change that, okay, as if both are executing simultaneously. We can't, the switching between them is so small that we cannot actually detect it. And we get the feeling as if both P1 and P2 are simultaneously executing. This is how time sharing works. Okay. Is it clear or not? Tell me that first. Is it clear?
Yes, sir.
All of you, is it clear?
Yes, sir.
Sure.
Yes, sir.
Only 2-3 responses. Rest. Is it clear to everyone? Please tell me.
Yes, sir. Clear.
Yes, sir.
Yes, sir.
Yes, sir.
Acha, one thing. Tell me one thing regarding the multi-processor system that we have seen. Which one is more reliable? Single processor or multiprocessor? Which one is more reliable?
Multiprocessor.
Why is it more reliable?
Because सिंगल प्रोसेसर एक ही टास्क करेगा और उसी टाइम पे मल्टी प्रोसेसर 2 टास्क कर लेगा.
वो तो एफिशिएंसी आ गया. एफिशिएंट ज्यादा कौन है? रिलायबल कौन ज्यादा है?
मल्टी है सर. टाइम
क्यों?
सर फास्ट है और टाइम कम हो रहा लग रहा है सर एक प्रोग्राम टास्क पूरा करने में.
वो तो एफिशिएंसी है ना, एफिशिएंसी कहते हैं उसे. Which one is more reliable?
Reliable what?
Which one is more reliable? I can rely, I can believe more in which of the systems? Tell me. That definitely, if I perform some task over either multi-processor or single processor system, any of them I want to perform a task on, okay? Definitely I will get a result. Chances of getting the result out of any of the systems is more somewhere. That more is more reliable, I can say.
Single processor.
Why?
Because मल्टी प्रोसेसर में इंटरप्शंस आ सकते हैं. सिंगल
इंटरप्शन आएगा?
जैसे कि हाँ, जैसे आपने बोला था कि T5 अगर अराइव होता है और चारों प्रोसेसर अगर बिजी है तो वो इंटरप्शन करेगा किसी ना किसी को कि आप खाली हो या नहीं पूछने के लिए. दैट्स द टाइम कुछ हो
ऐसा नहीं, वो
सकता है.
ऑपरेटिंग सिस्टम ट्रैक रखेगा कौन खाली है कौन खाली नहीं है. वो ऑपरेटिंग सिस्टम पे छोड़ दो, ऑपरेटिंग सिस्टम पे छोड़ दो, वो ट्रैक रखता है अपने आप. तुमको आज तक आया है ऐसा कुछ? सिंगल प्रोसेसर में नहीं आता भाई, तुम बोल रहे हो मल्टी प्रोसेसर में आ जाएगा.
ओके.
उसके हिसाब से डिजाइन होता है ना ओएस सर.
ऑपरेटिंग सिस्टम डिजाइन करने वाले यार लिनस टॉरवेल्ड्स है. हिसाब कर रहे हो कौन आदमी बैठा हुआ है पीछे? Okay, see one thing. In a single processor, let's say single processor system is there. If this processor fails, can I execute any task inside the given system? This is a system with single processor only. If this, suppose if it damages out, it has performed many things, so it will damage. It will kharab ho gaya system. If this fails, can I perform any task over this system again? If the processor itself fails?
Cannot, sir.
Okay, but if any of the processor fails in multi-processor system, can I still perform any task inside it?
Yes, sir.
Why?
Yes, sir.
Because 3 processor else are living there, right? So multi-processor system are more reliable. Definitely, if one processor is failing, I can execute my task on another processor. That is the advantage of multiprocessor system. It is more reliable.
But single is cheap than multi-processor.
But yeah, this multiprocessor has many advantages. चीप तो चलो समझ में आ गया, हमारे लिए है, चल जाएगा, ज्यादा कुछ करते भी नहीं, 2-3 पाइथन का कोड लिखते हैं. But in real world, these things does not happen. Your computer cannot take load off. Okay.
Okay, sir.
So you require multiprocessor systems. Fine. Multiprocessor we have seen. We have seen what? We have seen time sharing. Okay. Any doubt you are having in these 3 topics?
No, sir.
Any doubt, please ask.
No, sir.
Now let's see what is the advantage of time sharing. What is the advantage of time sharing? What advantage you can take out of time sharing?
जो सर मल्टी में होगा वही होगा सर.
Maximum utilization of the resource.
Maximum utilization of CPU, right? Maximum CPU utilization. CPU can be utilized to the fullest. Whatever is the capacity, I can take the maximum output from a single CPU itself. If a CPU can execute, has the capacity to execute 100 tasks, I can freely assign it, let's say 75 tasks to do. It can at least in real time can be assigned to 75 tasks, and it will manage it using time sharing. Okay, so if I have multi CPU systems like this, and each one of them acts like a time sharing, what can be the maximum processes that we can execute at 1 unit of time? Let's say I have 4 CPUs, and each one of them is acting as a time sharing machine. Then what is the maximum number we can, inside a multiprocessor system, we can execute at a unit of time not more than 4 processes. But each of the system, if I treat them, each of the CPUs, if I treat them as in they are utilizing the time sharing feature, I can execute 300 processes in 1 unit of time. As compared to 4, I can execute 300 processes at 1 unit of time. So process per unit is more. Okay. What else? Response time decreases, right? Response time decreases.
So please repeat the previous one.
Okay, yeah. Leave it as of now. Leave it. Maximum CPU utilization, right? Imagine that we have a single CPU. In 1 unit of time, it can have not more than, let's say, 1 second is the unit that I am treating. That okay. In 1 second, how many tasks this particular CPU can perform? Not more than 1, right? This has to be inside a single processor system. It has to be idle, right? Till it executes task T1, it should be sitting idle. All the processes T2, T3, T4, if I bring here, they had to wait. Such because T1 is inside it already. But if this single processor is time sharing, if this is a time sharing, what I can say is that 1 by 1, using some nanosecond feature, I can utilize this CPU for executing T1, T2, T3, and T4 all. All can be executed to some percentage in 1 second of time. I can say that, right? So I say that, okay, CPU utilization, the task that I can take out of a single CPU, that I can take out, sorry, output that I can take out from a single CPU is more as compared to any other systems, right? Inside time sharing. A single CPU itself is executing 4 processes in 1 second, right? So task that I can take out of a single CPU in 1 unit of time is more. Now we can say response time for a process is less. What do you mean by response time? What do you mean by response time? See, what do we mean by?
जल्दी कर देना, response कर देना sir.
Okay, say I want to go inside this folder, right? I want to go inside this folder. In how many seconds does it open?
Sir, millisecond कुछ.
Millisecond, तुम तो देख पा रहे हो, 1-2 सेकंड तो लगा ही होगा खुलने में टोटल, राइट? 1-2 सेकंड लगा या नहीं, बताओ इस फोल्डर को खुलने में?
Yes sir.
Is it? So see, what I did, I made 2 clicks. I clicked the icon. To open it. That means once I clicked, operating system got to know that user wants to open the folder. Open folder, okay? So it created a process. That, okay, this particular folder has to be opened. So this created a process of opening it. Okay. It created a process of opening it, and within 1-2 seconds, I got my result, right? I don't have, now suppose my present CPU does not have time sharing feature. Time sharing feature is not present inside my current CPU. Then what would have happened? Let's suppose inside my current CPU, my open board is running. Right? A task has been executed. That is open board is running. That task is currently going on inside the CPU. Now, suppose if I click the icon, will it ever open, or I have to wait till the time I close this open board? Something like that I have to do, right? I have to close this open board such that I get to execute the folder opening. But this is not the case right now, right? Why? Because my current processor is time sharing. Okay, it is allotting some time. It has allotted some time to open this folder, as well as it has allotted some time to run this open board also. Okay, in some time sharing manner, it is running both the processes, so I can execute both the process. I don't have to wait for a new process to bring result after 1 hour. This new process can give me a result within 1-2 seconds only. So I say that, okay, till the time when I start my process, I don't have to wait for half an hour or 1 hour to get the result, because some other process is running. So I say that, okay, I get the response or I get the output once I start a process in some 1-2 seconds. So I say response time for getting result of a process is less inside time sharing, is way less than any other systems. Is it clear? Tell me that. Clear है या doubt है?
Clear है.
All of you, is it clear?
Yes, sir.
Okay, so how many types we have seen?
3 types.
3 times: multiprocessor, single processor, and time sharing. Is it?
Yes, sir.
Fine. So one thing, okay, one thing, see. There is another term called multi-programming operating system. Multi-programming. What is it? What is it? Can anybody get any idea of it? Multi-programming. What is it?
कई प्रोग्राम एग्जीक्यूट करना एक संग सर.
टाइम शेयरिंग भी करता है. क्यों मल्टी प्रोग्रामिंग ला रहा हूं मैं? करता है ना, टाइम शेयरिंग हो, मल्टी प्रोसेसर हो.
यस सर.
सबको तो कई प्रोग्राम्स रन कराते हैं एक साथ. Any idea? Anybody can tell? Multi-programming. Multi-programming. What do you mean by that? What do you mean by that? Multi-programming. What do you mean by that? Multiple programs, right? Multiple programs. Multiple programs or tasks. Programs or tasks, I say, can be executed by a system. Now, only one difference is there. Only one main difference is there between multi-programming and time sharing. What is it? Time sharing can be utilized by more than one user. More than one user can simultaneously utilize this time sharing operating system, but multi-programming is applicable for one user only. Only one user can utilize a system that is multi-programming, but if it is a time sharing system, more than one person can sit on the same CPU and can utilize them one by one. Getting the point? No other significant difference is there. Okay, tell me. Now you can define multi-programming or not? Same, all other things will be same inside multi-programming. Multiple tasks will be running inside the system one by one, but inside time sharing, what will be happening? What will happen? Inside time sharing, what will be happening?
More than one person user matlab.
More than one users can operate on the same CPU.
So in multi-programming, how it is one user?
It is programmed in such a way that not more than one user together. Right now you're opening an operating system, is it? Can this same operating system be opened on some other system, or is it confined to your system only? Inside your laptop only this operating system can open. Is it? Or can I have some instance, can somebody else also control this operating system from your laptop? Can it be happening? The main thing is nobody else can have a control. Let's say your operating system is this. Okay, I cannot have two accounts simultaneously running it. Okay, same account, two accounts cannot be there. Two accounts user accounts I cannot have inside my system such that both will be running this operating system at one go. Only one can run it. I have to log off this. To start this account. or I have to log off this to start this account. Anyone can only run it, not both together. But if it is a time sharing, I can say that, okay, using two different accounts, I can run this instance of operating system. I can run this instance of operating system together, okay, for some time. How is it time sharing? For some time. Sometimes it will be executing the process of this account. Sometimes it will be executing the process from this account. Getting the points? This is an advantage of time sharing.
इसलिए में सर
Yes.
सर थोड़ा बहुत तो टाइम डिफरेंस होगा ना सर इन दोनों में?
इसमें देखो ये कॉन्टेक्स्ट ही अलग अलग है, ठीक है, कॉन्टेक्स्ट ही अलग अलग है. थोड़ा बहुत टाइम डिफरेंस कैसे होगा?
क्योंकि सर है ना वो मल्टीपल कर रहा है, जैसे कि टाइम शेयरिंग की बात करें तो जैसे कि सुपर कंप्यूटर, तो वो सर एक बार कई सारे यूजर को वो कर रहा है सर, ऑपरेट कर रहे हैं.
टाइम का डिफरेंस क्यों होगा? दोनों एक साथ रन कर रहा है, दोनों की प्रोसेसेस सेम ऑपरेटिंग सिस्टम पर रन कर रही है. कुछ कंप्यूटर तो बहुत एफिशिएंट होता है ना, कंप्यूटर का जो मेमोरी है, सॉरी प्रोसेसर है, वो सबसे फास्टर कंपोनेंट होता है.
यस सर.
ठीक है, तो ये क्या कर सकता है साइमल्टेनियसली सारे इसके कुछ प्रोसेसेस को, इसके कुछ प्रोसेसेस को 1 by 1 प्रोसेस कर ही सकता है. ये कंप्यूटर की पावर है भाई, क्या सोचा हुआ है ऐसे?
नहीं सर हमको लगा ना, क्योंकि सर टाइम शेयरिंग में बताया आपने कि सेम वैसा ही होता है, तो सर जो
बस इसमें मल्टीपल यूजर्स काम कर सकते हैं. मल्टी प्रोग्रामिंग कैन हैव only one user at a time, but multitasking can have multiple user accessing the same operating system 1 by 1 simultaneously, not 1 by 1, simultaneously. Okay.
सर कोई एक लाइव एग्जांपल बताइए कि जैसे हम कुछ कर रहे हैं.
लाइव एग्जांपल तो मैं भी नहीं बता पाऊंगा कि तुम्हारा टाइम शेयरिंग कहाँ यूटिलाइज होता है, तो देखना पड़ेगा मेरे को.
चलो वो मैं समझ ले कि हम गूगल का सर्वर एक्सेस कर रहे हैं.
हाँ.
एक ही फाइल को हम दोनों ऑपरेट कर सकते हैं.
कर सकते हो.
गूगल डॉक्स वगैरह शेयर करते हैं, तो उसमें क्या करते हैं कि हम मल्टीपल यूजर हम वो डॉक्स में सेम फिलअप कर सकते हैं.
यस.
तो वैसे टाइप का है क्या?
कह सकते हो. सर्वर्स के करस्पॉन्डिंग जो वो ऑपरेटिंग सिस्टम्स यूज होता है. ठीक है, अब एक सर्वर जब होता है उसमें कितने लोग कनेक्टेड होते हैं ना, कितने लोग डेटा रिक्वेस्ट करते रहते हैं साइमल्टेनियसली. तो वी कैन से दैट ओके हियर अ सिस्टम इज रनिंग, an operating system is running which is doing what, sometimes कुछ टाइम इसको दे दिया, कुछ टाइम इसको दे दिया, कुछ टाइम इसको दे दिया, कुछ टाइम इसको दे दिया. 4 different users are, let's say, acquiring this database, this system, okay, simultaneously. So it is doing what, executing the request 1 by 1 of each, for each of the.
मतलब सर वो एक पर्टिकुलर एक सिंगल टास्क को लोग परफॉर्म करेंगे क्या? हर एक यूजर अलग अलग टास्क ले सकते हैं. पर्सन 1 जो है
हाँ अलग अलग कर सकते
फाइल ओपन किया है,
इसकी प्रोसेस P1
गूगल दे है.
हाँ, इसकी वो बात नहीं है. तो ये तो एक पर्टिकुलर, मान लो कि मैं गूगल ही के सर्वर में हूँ, गूगल के ही सर्वर में मैं काम कर रहा हूँ. ठीक है, तो तीन लोगों ने गूगल के सर्वर से कोई रेस्पेक्टिव पेज को रिक्वेस्ट किया. दिस इज P1, P2, P3. 3 persons are there who were requesting some pages. It requires page say, let's say it requires page C1, page C2 is requested by P2, page C3 is requested by P3. They may be or may not be same, but all have requested in the same time. So what it will do, it will process each of them 1 by 1. Sorry, it may process each of them simultaneously. Give some, it will divide the time among these 3 requests. Okay, sometimes some part of the request of this will be executed, some part of this, some other time some part of request P2 will be executed, and some other time some part of request of person 3 will be executed. And we can say bit by bit the time in which response will be going out, we can say that okay, this will be almost similar time in which both the 3 persons will be getting the response. Okay, it gives in 1 second, let's say, it gets back in 2 seconds, it gets back in 3 seconds. Not much, but yeah, depending upon what the request they have made. Someone might have requested very small, someone might have requested very big searching request. Okay, So what may happen is them in between three of them, some time limit will be given that for first 5 seconds, person P1's request will be executed, then P2's, then P3. Similarly, this entire process will go on till the entire request gets executed, and they will be the result will be fetched and the result will be sent to the respective users. Similar things can happen inside a server architecture, but these things are more advanced. What we are talking exactly is the same case may not be there. Server is quite critical thing. Okay, server is quite a critical thing. Tell me, whatever we have discussed, is it clear to all of you? First, tell me that. Live example, better I will come back to you tomorrow. That what may be the live example of multi time sharing systems. Let me see what can be more appropriate example of that.
सर टाइम शेयरिंग का एग्जांपल सर हम वो ले सकते हैं सर, राउटर
राउटर ऑपरेटिंग सिस्टम नहीं है ना
सर, प्रोसेसर तो लगा हुआ ना कि सर है ना, वो एक बार में सबको डिस्ट्रीब्यूट कर रहा है।
प्रोसेसर का काम तब जानोगे ना, सॉरी नेट क्या बोला तुमने, फिर से बताना।
क्या सर?
क्या बोला, कौन से एग्जांपल के बारे में बोल रहे थे?
सर राउटर।
राउटर के बारे में तब जानोगे जब नेटवर्किंग पे आएंगे। ठीक है, राउटर करता क्या है, कैसे करता है। Clear to all of you how multi-programming and time sharing are differing. I will come with the example of time sharing, better example of time sharing tomorrow. Then let's see what can be better example for time sharing for a better understanding. What is the difference? Main difference is more than one user can operate on time sharing operating system, but inside a multiple programming, it is not possible. Okay. Clear to all of you or not? Tell me that.
So the system we are using, that is multi-programming.
Yes, multi-programming systems, not time sharing feature is there, but time sharing is in terms more advanced. That okay, more than one user person can access the same operating system, one same processor, we can say, together. Okay, and the operating system will be managing that. That how the time should be divided between both the users. Okay, time sharing is an extended version of multiple programming system. Okay, is it clear to all of you? Please tell me that.
Yes,
Clear
sir.
or not?
Clear, sir.
Sure.
Yes, sir.
Now let's come to one thing. Let's dig deeper into the programming. What is into the operating system? What is a process? What do you mean by process? What do you mean by process? What do you think?
सर टास्क का होना प्रोसेस कहलाता है।
कौन से टास्क का होना?
सर कोई भी टास्क हो रहा हो।
ठीक है, फिर भी
So
more.
whenever we give any input, that process and then gives output. So like
What
that.
is so? What is a process then?
टाइम लगने वाला,
Executing of work.
टाइम लग रहा है एग्जीक्यूट होने में।
Program under execution is called a process. Program under execution is called a process. We were running our Python programs in our previous class, is it? The code, once we were writing the code, and after writing the code, we were running it, is it? .py files, right? We have written the code, then we were running it. This running,
sir.
when it was running to the, when it was going to the running state, this state was this particular state in which this entire process was running, entire code was being executed. This state of running the program is called a process. We given the instructions here and asked our operating system, okay, I want to execute this code into an application called VS Code. I want to execute this code into an application called VS Code. Then operating system will do what? Run this particular code into the VS Code, okay? And then this VS Code will give us the necessary output. Okay, the time, the program, the Python code that comes under the execution inside the VS Code, this running state is called output. Sorry, this running state is called a process. Okay, process is what? A program that is being executed. This entire thing is called a process. Okay, now there are several states of a process. Process has several states, not states, but several stages. Okay, let's say I have given that, okay, this is my Python code. This is my Python code. I want to run it. I want to run it. Or I want to execute this entire code. So what will happen when I will give the command to run it? It will first go to start. It will go to a stage called start. This is the initial state when an entire process is being created. The process of running my code will be created. Process created. Sorry. Process will be created. First stage. That is called start. Okay. Now the process has been created. What will happen? It will be going to a stage called, it will go to a second stage called a ready state. After being created, operating system will indicate that this particular process, which has been created by the user, which was being which was being requested by the user to be executed. This is now ready to be executed. Okay, this is now ready to be executed, and inside this ready state, this process waits. This process waits to be assigned to a processor. To be assigned to a processor. That okay, right now I am ready to be executed. I need a processor. I need a processor for getting executed, for getting my codes to be executed. Fine. So second stage is called the ready state. Now third stage. After this, there is a third stage called a running state. It was waiting for a processor to such that this processor will be executing the commands inside the process. Now what will be happening is that inside third stage, it will be getting executed, and that particular executing phase is called running state. It was ready state. Okay, this program can get executed now. Now, after this ready state, it goes to another state called running state, in which processor executes it. Processor executes it. Fine. Okay. So we have seen that several processes are being switched. Okay, if there is a single processor, it will switch between various processes. So once I have executed some part of the process, okay, it may be put to wait stage. It may be put to wait stage. That okay, wait for some time. Wait for some time. I will wait for some time. Operating system will tell that this particular, let me write wait here. This particular process after being executed for some time has to wait such that it will be executed again after some point of time. Fine. And once this has finished execution, let's say the after all rounds of execution are done, we can say this has completed, or we can say this process now is being terminated from execution. Is being terminated from execution. This is the fifth or last stage. So how many stages are there? 5 stages. First, when the process is created. Next, when it is after getting created, it becomes ready to be executed. Third stage, when it will be running, processor will be executing all the commands present inside the process. Now next, it will be it may be put to waiting sometime. Sometime it may be put to waiting. Okay.
So wait for what?
Wait for your turn. Next, for first 5 nanoseconds, process has been executed. Now it will be asked to wait. Wait for 5 nanoseconds. Okay. Once your wait is over, we will again execute. Okay. For first 5 nanoseconds, it is being executed. Now it will be made to wait for 5 nanoseconds more. And till then, this process will be executed. This is how your processes works. Okay. Time sharing, we have seen. For first 5 nanoseconds, this process was being executed, and then it will be made to wait for another 5 nanoseconds. At that time, this task T2 will be executed by our processor. Okay, so that is called a wait stage. And when the entire execution is over, we say that okay, the process is being terminated, or it has.
It will be terminated when it shows the output.
When it be, or some other, let's say some error is coming to run the program, that time also it may be terminated.
So whatever it is, then it is last, that is terminated.
Yeah, that is the last stage. So as a whole, we have some diagram to represent our process states. Okay, at first it starts. There is a start stage. Okay, then it goes to ready state. Fine. Next, it goes to running state. From running, it may be made to wait. Okay, it may be made to wait. It may be made to wait. And then from wait again, it has to go to ready state for getting executed. Such that from ready again, it will go to the running state. Or we can say that from running, sometimes it may be put to the ready state again. Sometimes it may happen that it may be put to the ready state again. Operating system, if finds necessary, it can do that. Now, once after running, it has been executed, it may be put to terminated state. Okay. It may be put to the terminated state. Fine. So this is.
It may wait or it may not be wait. No, it's not compulsory that it will wait.
Let's say this is a time sharing system and we have a process. Very vague example though, it may not happen at all. We have a process. So it is in running state, 5 nanosecond, it is completing. So what will happen is that if there is no other system, it may wait for some 1 to 2 nanoseconds. Very vague example it is. Okay, 1 to 2 nanoseconds, it may wait such that operating system checks that, okay, is there any other process to be executed? If not, then again, this particular process will start. But yeah, it has to wait. In ideal scenario, every process has to wait for some time. You cannot say that a process, single process will be running or no more processes will be there. It is not the case in real-time environment. Every process has to wait at least for some time. That's why a wait state is necessary for inside every operating system. Okay, but what may happen is that operating system can directly say that you don't need to come, the process don't need to come to wait state, rather go back to the ready state. We will pick you up from here again after some time. Okay, sometimes something like this may happen, but waiting is 100%. It will happen. Okay, so there are as a whole 5 states: start, ready, running, terminated, and wait. Terminated is the last state when process either gets devalidated, the CPU finds some error inside it that, okay, this cannot be run anymore. We are getting some errors here. Put to the terminated state, and user will be asked to please rectify your code. Whatever you have written is not correct. Or once it has completed, given some output, completed its execution, then it will be put to the terminated state that, okay, our entire process is done. You can start some. If the user wants, you can start some other processes as well. Clear to all of you, all the processes, how they are happening? Tell me that first.
Yes, sir.
All of you, tell me that.
Yes, sir.
Okay, want to go ahead or shall I stop today here? Tell me. So one thing, see, inside the ready state, actually this ready state indicates a priority queue. There are a lot of jobs waiting here, lot of jobs in ready state to be executed by the operating system. Fine. So what will happen is that all these jobs are kept inside a priority queue data structure. Okay, inside the highest priority job is put to the processor. The highest priority job J is put to the processor for getting executed. Now, once it has been executed for some time, for some particular amount of time, it will be put to the wait state. Okay, it will be put to the wait state. Now, some lesser priority job, then J will be after J has been removed from this priority queue, this will come as a more prior job to be done. Now this will be put to the processor for getting executed. Similarly, your jobs are being extracted from this priority queue data structures, put to the processor, and they are being executed there. Okay, so one data structure that we know is priority queues that are being that is being used to keep the jobs that I want to execute with some priority. Okay, and that from among those priorities, we extract jobs one by one and put it to the processor for executing. We will see how those priorities are being assigned and what kind of processes are actually there. Okay, this entire thing is called a priority queue or job queue. Entire thing is called a job queue rather. Inside a job queue, all ready state jobs are assigned. Operating system allots these jobs to the processor one by one. Fine. And moreover, another term I should tell you. One process, when processor is already executing task T1, now it switches, it removes the task T1 from itself, and task T2 comes in to be executed inside the processor. This exchange of processes inside a processor is called context switch. It's called a context switch. Okay. What process is to be executed inside my current processor, that is changing. That change is called a context switch. Okay. And which process will be coming inside, that is being taken care by something called that is being taken care by a software. Okay. That is called as a job scheduler or a scheduler. Job scheduler actually takes care of which job right now has to be executed inside my current processor. Okay. A software we have called job scheduler for that. Okay. Are all these things clear today? Tell me that.
Yes, sir.
Sure.
So can you repeat the content switch?
Which one? Sorry.
Content switch.
Context switch means okay.
Context switch.
Here we have a processor. We have a processor, right? Now what will happen is that we have a processor and initially it was having task T1 inside it. Now it has completed some part of execution. Let's say for 5 nanosecond, task T1 has been executed. Now it will go out of the processor and T2 will be coming in into the processor for getting executed for another 5 nanoseconds. Fine. So this exchange, this change of process inside a processor, which T1 was earlier, but it has now changed to T2. The changing of process inside a processor is called a context switch. Okay.
Okay, sir. But after execution of program, there will be some time for T2 for execution.
Yeah. That change is called a context switch. Now see, one thing is that, okay, tell me, how many of you have taken user inputs for while running a code? User inputs.
बहुत बार.
कितनों ने लिया है, कितनों ने नहीं लिया? अभी तक मुझे बताओ.
हाँ, लिया है.
How many of you have taken user inputs from the console?
Yes, लिया है.
एक ने लिया है, बाकियों ने? Okay. Three persons have taken, I guess. Next.
Yes, sir, we have used it.
Okay, 4, 5 have done that, and rest I was.
use किया है.
Okay, 6-7 ने किया है क्लास के. बाकियों ने अभी तक नहीं किया. ठीक है.
सर क्या?
कंसोल से इनपुट कितनी बार लिया है पहले बताओ.
मतलब सर
कंसोल से इनपुट, अरे कंसोल से इनपुट देते हो ना, प्रोग्राम को रन कराते वक्त इनपुट डालते हैं हम लोग नीचे के ब्लैक बार में.
यस सर.
फिर वो इनपुट जाता है प्रोग्राम के अंदर, राइट? फिर जाके वो आगे एग्जीक्यूट होता है. So see, these things are called IO times. Whenever we run a code, whenever we are running a code, and inside this code, input will be given at the runtime. While running it, I will be giving some input from the console. So what happens is that this process has to wait. This process has to wait for what? This process has to wait for getting input from the user. So this particular waiting time is called IO time, input output time. At that moment, we say, this your wait time dekh rahe ho na? Where is the wait time, man? This wait time you are seeing, what is a wait? More appropriately, we can say, when a program was running, now some part has arrived, some code has arrived such that I want this program for running further will be requiring an input from the user. Input from the user. Then what happens is that it comes under waiting state. That is to a case when a program comes under waiting state. And so it was waiting for, it is waiting for getting input from the user. So till that time, operating system will do what? It will into the processor, it will give some other process to execute. Whatever is present inside the ready state, this will assign to it. Any other process will be assigned to the processor for getting executed, and that process will be coming under the running state. Once I give any input, once I give further inputs to program that was earlier running, okay, now it is ready. Now after giving the input, it is ready to be executed further. So it will go back to the ready state. It will go back to the ready state. And then once the execution of the new program that I have given, while this program P was in wait state, I have given some new program, or the operating system has given new program to the processor for executing. Once it is done its part, then again from the running state, this process will be fetched and given to the processor for executing further. Okay, this is how actually it is being managed by the operating system. So those the weight a process does for getting input, weight process does for getting input or showing the output to the user, for getting input or giving, for input output. Okay, this particular thing is called IO weights, IO wait time. Process has to spend some time or give some time for taking the input from the user or giving back the output after executing the entire program. These are called IO wait. Okay, process called IO wait. More appropriately, if I have any code to run, I can show you that. Let me see. Which program shall I run? This is what I am saying. This is test 2. Okay, yeah. Let's say this is my code. This is the code, and let's say फायदा नहीं है इसको लेके, ये बहुत बड़ा प्रोग्राम है. Anything that can be done here? फायदा नहीं है, चलो इसको देख के दो. Let me show a TC file here. यार कोई प्रॉपर कोड मेरे को मिल नहीं रहा है जो कि मैं दिखा पाऊँ कैसे ये एक्चुअली ये IO wait हो सकता है. Fine, let's do this. Okay, see. Okay, once I give it compile and run, at that moment it is this. I have to wait some time, right? The process was being created before the black window has appeared. Process was being created, and after getting created, now this has come to the running state. But see, for getting some input, this is waiting, right? Right now it is in wait state. After created, execution has started, and it has to get some input from me, from the user. That's why it's waiting. Now I give a user, let's say input, let's say 5. What is it? So what had happened? It has taken some amount of input and has given the output as 3. So before getting terminated, before completing the execution, let's see, it has waited how many time? It has waited for me to give the input. Now still it is in wait state. Why? It is showing me the output as 3. Okay. It is showing the output as 3. The last output 3 has been printed out. It is for showing me the output. It is still waiting. Now once I print enter, process has been totally executed and terminated. Okay. So this is how we can say that when it waits, as it has to wait for getting some inputs as well as to show the output. Fine. This is how a process works. Okay, let's stop here today and we will carry out our discussion tomorrow. Tell me, whatever we have discussed, is it clear to all of you? many things I guess we have discussed today.
Clear है sir.
Sure. Tomorrow some maths related topics we will be discussing. Mm. I've given the first MCQ. created the attendance, please mark all of you. And आज किसका किसका इंटरव्यू हो गया? How was it? How was it? Okay, what questions were asked today? Okay, good night, all of you. Thank you. So we are almost in the last week of our syllabus. चलेगा क्या सौरभ? या हो अभी भी?
हूँ, अभी भी हूँ।
बताइए क्या हाल चाल है जनाब?
सब बढ़िया सर।
और तुम कब है इंटरव्यू बाकी आप लोग का?
अभी तक शेड्यूल नहीं किया।
कितने दिन में करना है? एज इन कितने, पूरा वीक चलेगा या 3 दिन में हो जाएगा?
पूरा वीक है शायद। कल तो स्टार्ट हुआ ना।
थर्सडे तक है सर लास्ट।
थर्सडे है लास्ट।
ये दो अच्छे से। आज क्या क्या पूछा? शायद किन्हीं ने दिया है इंटरव्यू?
कल के रेस में 4 लोगों का दिख रहा था, बट उनका कैसा हुआ क्या हुआ पता नहीं चला।
ओके।
और आज मैंने सुबह से देखा ही नहीं।
चलो सही है, दो अच्छे से।
मैं परसों दूंगा।
लगता नहीं ज्यादा टफ पूछेंगे इस बार।
नहीं, कल मेरा ट्रैवलिंग में जाएगा ना इसलिए।
अच्छा, कहाँ जा रहे हो?
आगरा
घूमने?
नहीं, थोड़ा काम है।
आज महल देखने?
नहीं सर, पता नहीं, देखने मिलेगा भी नहीं।
आगरा में एक ही बार गया हूँ आज तक। ओके फाइन, गुड नाइट ऑल ऑफ यू।
गुड नाइट सर।
गुड नाइट या
गुड नाइट सर।
या गुड नाइट।